All right. So we are moving on to 5.1, ready, set, go, number 16. And it's this problem here. So don't be intimidated by word problems. Word problems actually make more sense if you just take a second to read it. One of the strategies that is out there right now is reading the problem over and over again, and each time having a different focus on it. So I'm going to read this problem and I'm just going to understand it. And then I'm going to read it to get all the information out of it. And then lastly, I'm going to read it with the understanding of what I'm supposed to find it. So it says a large waffle cone has a diameter of 3 inches. There's my 3 inches and a height of 8 inches. Okay. And then 2 scoops of ice cream has been stacked on top of the cone. Which you don't see, right? You have a scoop of ice cream here and a scoop of ice cream here. After it was filled. So you filled up the cone. Okay. Like you like filled it up. So imagine like soft serve or something where it's like changing the shape into that cone, right? The ice cream is like forming to that cone. The scoops are completely round and have a diameter the same as the cone. So they give me some formulas, and then it says find the volume of the 2 scoops of ice cream combined with the ice cream inside of the cone. Okay, so I get it. So they're having me find the volume of all the ice cream that fills this cone to the brim, and it's flat. Can you just imagine it's flat at the top. And then it also has 2 perfectly round spherical scoops of ice cream. Okay. So again, a large waffle cone has a diameter of 3 inches. Got it. 8 inches. Got it. 2 scoops of ice cream. I can't forget those 2 scoops. So right now I am going to draw in my 2 scoops of ice cream. I'm not going to draw them on top of them because it's going to take over there. So just pretend that it's that I'm a really good drawer. And you guys are like, wow, Miss Johnson. Yeah. So I just need 2 of these. This is kind of how I draw my spheres. That was okay. Kind of looks a little bit like a fat circle instead of a round circle. Okay, so 2 scoops of ice cream have been stacked on top of the cone. So 1, 2. So I'm going to do this, and then I'm going to just put it times 2 because Miss Johnson, she drew 1 circle that was kind of circular. So we're just going to stop right there. And it says the scoops are completely round and have a diameter the same as a cone. Okay, so I need to write that in. So my diameter here is 3 inches. Okay, and I'll put a little thing here. So usually, just so that you know, when I draw something and I want you to know that it's the diameter, I draw it and then I draw this little dot right here, indicating that that's the center of my circle or my sphere. Okay, so this is 3 inches. And then I'm supposed to find the volume of the cone plus 2 ice cream scoops. Okay. All right. So there we go. So here's my volumes. Here's the my formulas. So all I really need to do is find my R, find my H, find my R, and then do 1 of these and 2 of these. So I'm just going to go like this, plus, and put a big old plus there. And that's how I'm going to find my formula. Okay. So the volume of a cone says right here. So I'm going to go 1/3 pi R squared H plus 2 of my spheres, which is 2, 4 times 4/3 pi. And I'm just going to use a little parentheses right here just so I can put that in there. Does that make sense? So I'm actually going to erase my H here and my R here, and I'm going to put parentheses instead. And then I'm going to fill in everything. Okay, I'm just going to fill in everything. So for the cone, for this cone right here, what is my radius? Now, don't get fooled. Okay, don't get fooled. Don't be like, oh, it's this. They're asking you for the radius. So what's the radius of this cone? Yeah, it's 1.5. Now, I don't know about you guys. I will tell you my preference. My preference is always fractions because it's easier to square a fraction than it is to square a decimal. So I'm going to write this as 3/2. You can do whatever you want because, we're going to be using a calculator anyway, but my mind tends to think more efficiently in fraction land. And then it's going to ask you for your height. And so you're like, okay, well, what's my height here? What's my height here? And you're like, oh, it has to be H is equal to 8. So exactly. So can you plug this into your calculator? Yes, you can plug it into your calculator. So I'm going to move on to this side. So 2 times 4/3 pi r. Notice this one doesn't have an h, right? But the h actually in this case is the same thing as the r, which is why that's why it's going to be multiplied. So sorry, that's not true what I just said. Let me take that back. The r in this case has to do with the h in this case. I'll say it like that, right? Because remember, the radius can go this way and this way and that way and that way. It's just like the spokes of a wheel. Do you guys all see my bicycle wheel? And the spokes are coming out of it. You guys all see that? Yeah. Okay. So the radius in this case, it's the same. It's 3/2. So I am going to simplify this because I want you to see that you can simplify this. This is not that horrible. So when I simplify this, I'm going to get 1/3 pi times, Ms. Johnson, how do you square a fraction? Go back to the definition of squaring, right? So squaring means multiply it by itself. So this is literally going to be 3/2 times 3/2, which is 9/2. Oops, 9/4, my bad. Times 8. And you can see some math happening here, right? You can see some math canceling here everywhere. So I'm just going to continue. Plus, over here, I got 2 times 4/3 pi. So if 3/2 squared is 9⁴, 3/2 cubed would be this times 3/2, which I think is 27/8, right? So you guys are like, Ms. Johnson, can't we just plug it in? Yes, absolutely. But I'm going to go this long way just to show you that it's not that horrible. So I'm going to simplify this 9 and this 3, leaving a 3, this 8 and this 4, leaving a 2. So here I have 6 pi. That's encouraging, right? And then here I can simplify a bunch of stuff too. Look at this 2 times 4 is 8. This 2 times 4 is 8. So I'm going to cancel those, because 2 times 4 is 8, divided by 8 is 1. And same thing goes here. 27 divided by 3 is 9, right? So 2 times 4 is 8, so 8 divided by 8 is 1. 27 divided by 3 is 9. So this is really just 15 pi. A lot simpler for me to plug in. If you don't believe me, no problem. Let's do that together. Let's see. Let's go this way. Yeah, that's good. Right here. That's not what I wanted. Here it is. There you go. I want Desmos. Can I squeeze you over here? Yeah, that's what I want. All right, so I get 1/3 pi times, let me move my hand, 3/2 quantity squared times 8 plus 2 parentheses 4/3 pi parentheses 3/2 close to the third. Did I do that right? Nope, that's fine the way that is. That's fine. So that I think I entered it in correctly. 2 times 4/3 pi r cubed. And over here we have, I can move this over a little because we don't care about the calculator right now. 1/3 pi 3/2 squared times 8. Always checking to see if I entered stuff in correctly because Ms. Johnson, you know her. I think my answer is 15 pi. What do you notice? Right. We did it right. Yay. Okay, very good. So there it is. Done. Everybody good on that? Done. Okay, so that's all they were asking. It seems a lot more intimidating when you read this problem. And then when we draw it out, we're like, oh, that's all you wanted? You wanted 2 spheres. That's why that 2 was there. We wanted cone. This means cone. This means sphere. Cone plus 2 of the spheres. We simplify and we get this thing. It's awesome to me. I don't know if this is very nerdy for you or not, but it is very nerdy. So I'm gonna own up to it. Where's my, let's see, this guy? Oh no, this guy went over here. Sorry. It is very awesome to me. Whenever I like look at something and it looks all crazy and complicated and the answer comes out super simple. I don't know. That just makes sense to me. So This is like one of those times that this wasn't that easy, but it should make sense, right?